ratios, and later in the week or at the beginning of next week we will look at rate. Ratios are very similar to fractions, and I'll show you that once we go over a little bit about individual ratios, and we have part to whole ratios, and then how we have part to part ratios. So when we have part to whole ratios, if we look at this little diagram I drew up here, which is just a series of balls, if I'm talking about whole ratios, I want to know how many balls are in the container. So I can just count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we have 14 in total. And because it's part to whole, the whole number goes second. Now, for example, if I want to look at red, so if I want to do red balls to the whole number of balls, I then count the red balls. 1, 2, 3, 4, 5, 6. So the part to whole ratio for red is 6 to 14. We can also write that as a fraction. So the numerator denominator is the same as the part to whole, which makes sense. If we had a chocolate bar in 14 pieces, that's the whole. You're getting 6 pieces, that's the part. If I wanted to look at the blue, I do the exact same thing. My whole has remained the same. I still have 14 balls, but I have 1, 2, 3, 4, 5 blue ones. And I can write that, I guess I'll keep my color coding going here. I can write that as 5 to 14, or again as a fraction, 5 over 14. So that's part to whole ratios. It doesn't matter what your parts and your whole are. If I was looking at a parking lot and I wanted to know the number of trucks versus sports cars versus motorcycles, if I wanted to do part to whole, I would count every type of vehicle there and then decide, oh, how many are motorcycles? How many are sports cars? How many are trucks? If I was at an airport, I could include helicopters and airplanes. So the whole, again, is everything you're looking at, and then we're looking at the part. So now we go to part ratios. And this time, instead of considering the whole thing, we're considering each individual piece. So for example, if I wanted to do the part to part of red to blue, I would count red, 1, 2, 3, 4, 5, 6. Could have looked over here as well. And then I'm going to count it to blue, which is 1, 2, 3, 4, 5. Again, it matches up there. So my part to part ratio, red to blue, is 6 to 5. Again, fraction, 6 to 5. If I wanted to do blue to black, again we have 5. And now we want to know how many black we have, which is 1, 2, 3. And we can write that fraction as 5 to 3. Now the important part about knowing that we have a ratio can be written as a fraction, that means for the ratios we can find the decimal by dividing top by bottom, or part to whole. We can find percent by dividing top to bottom times 100, dividing part to whole times 100. So we have this interplay, like I talked about so many times, that ratios will hit fractions. Fractions, we have lowest common multiple. Lowest common multiple, greatest common factor. All of these things that we've been learning start piling in now, so that once we've understood the first concept and can apply it, it makes these so much easier. The next part about ratios is I can now look to see if I can put these ratios into lowest terms. So remember when we're trying to find lowest terms, and I'll put that up here, we're looking for that GCF, or greatest common factor. So let's look at each of our examples. The first one we have for part to whole is 6 to 14. Well, I would need to factor 6 and factor 14, but I know that that greatest common factor is going to be 2, because the only thing that works for 14 are 1 times 14 and 2 times 7. For 6, it's 1 times 6, 2 times 3. So the only common factor is the greatest common factor. So I'll divide top and bottom by 2, which gives me a fraction of 3/7. And guess what? This becomes 3/7. We just write it differently. Next, I'm going to look at this, and remember, again, one of the very first things we did in math was look at prime and composite numbers. A composite number were like these. 1 times 6 works, 2 times 3 works. For a prime number, the only thing that works is 1 in itself. And I know from doing math for a long time, you'll know by looking in your math rule book at that front page where we did prime and composite numbers, that 5 is a prime number. And I know that 14 is not a multiple of 5. So this is already in lowest terms. Here, important to note, I have a fraction of 6 to 5. If this was fractions, I would want you to turn that into a mixed number, which would be 1 1/5. We don't do that with ratios. So we will leave this part-to-part ratio as 6 to 5. All right? There's no common factors between 6 and 5, so this is already in lowest terms. And look, we got lucky. Same thing. 3 is a prime number, 5 is a prime number. They're not multiples of each other, so this also is in lowest terms. So let's try one that I'm just going to make so that we can use this greatest common factor one more time. So what if I had 15 to 30 parts? 15 parts to 30 parts. If I'm going to factor 15, 1 times 15, 2 doesn't work, 3 times 5, and we're done. 30, there's a lot of factors of 30. 1 times 30, 2 times 15, 3 times 10, 5 times 6. So I look at these two sets of numbers, and I look for the greatest common factor. The thing I noticed in fractions is a lot of times you would find a common factor, so maybe you're going to choose 3 because it's in both. Or maybe you're going to choose 5 because it's in both. But the true greatest common factor is 15, and I found a lot of people missed it if the factor was the number itself. So we're going to turn this 15 divided by 15. If I write this as a fraction, 15 over 30. 15 divided by 15 equals 1. 30 divided by 15 equals 2. So our blue, actually I made this one up so it's not referring to anything. 15 to 30 in lowest terms for a ratio is 1 to 2. That is pretty much it for what you need to do in math today. It's part to whole, part to part, and trying to put it into lowest terms. If you're still struggling with lowest terms, don't sweat it. Remember, we talked about the most important part is understanding how these ratios and fractions work. All right, I hope everybody has an amazing day, and I'll see you tomorrow with more ratios.